guys, welcome to another amazing time with Mr. Moses. For today we'll be talking about the refractive index of a triangular glass prism. What is the refractive index? When we talk about refractive index just gives us a quantity that gives us a measure of how the speed of light slows down when it encounters a barrier. But in this case, for today, we'll be looking at two mediums when light passes through from air through to glass and out of the glass. So today we'll be looking at the refractive index of a triangular glass prism. So guys, from the last practical session that we discussed, I was able to tell us what the refractive index was, and the refractive index of any material, when we talk about the refractive index, just tells us how light slows when it encounters a medium. But in this case, we are talking about a triangular glass prism. Now, if we have a triangular glass prism, the refractive index normally is eta equals to sine half A plus dm all over sine half A. dm is equal to the minimum deviation, A is equal to the angle. Now, for a triangular glass prism, we have 60 degrees here, 60 degrees here, because all the angles are equal. So for a triangular glass prism, A here is equal to what? 60 degrees. Okay, now so we have some set of table of value, which is something like this. You will have your I, which is your angle of incidence, D, which is your angle of deviation, and E is your emergent ray. So we'll be plotting a graph. Of D against I. Plotting a graph of D against I. So just to let you know, please, if you are working on a graph sheet, ensure you use your pencil, but I'm going to use my Bible just because I want every one of us to see. So with this table of value, we'll be using the table of value to plot on a graph sheet. Now I'll be using 2 centimeter to 10 units on my x-axis and 2 centimeter to 10 units on my y-axis, where the y-axis is the deviation and the x-axis is I, which is the incidence in degrees. So the first one here, we have 30 for I and 39 degrees for D. 30 for I and 39 degrees for D. 39 degrees for D. Okay, get here. Okay, then the second one, we have 40 degrees for I and 37 degrees. 40 degrees here, say 37, this is 39, 30, 38, 37, something like this, 37. Then we have I 45, 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5 here. Then we have 39 again. 39 should be here. Then for 50, we have for 50 we have 41. 50 we have 41. This is 40 and this is 41. Then for 55 here, we're going to stop. 55 1, 2, 3, 4, 5. For 55 degrees we have, okay, for 55 degrees we have our deviation to be 45. 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. So we have this. So this is what we have. Now to the next thing, we will be plotting our graph. Now if you have a broom or a curve, you can use it. So for that, I will have my graph. Okay, this is try to use a broom. So this is what I have. I'm having a curve here. Yes, I think I'm having a curve here. So I think I'm having a curve here. So I'm having a curve. So this is what I have for my curve. Okay, I'm having a curve here. Yeah, so the next thing is to locate my minimum deviation. My minimum deviation is this. So where does my minimum deviation coincide? 40. My minimum deviation is 37 degrees. 37 degrees. So dm is equal to 37 degrees. So this point here is my minimum deviation. The tangent here is my minimum deviation. Okay, so if that is my minimum deviation, then how do I calculate? Given that our minimum deviation is 37 degrees, because after plotting our graph, we observe a graph. We have a U-shaped graph. That means we have a U-shaped curve, and the minimum, that means the lowest point here, gives us the minimum deviation. So if we have 37 degree to be our minimum deviation, then using the formula of the refractive index that says that the refractive index is equal to sine half, and given that our A is equal to 60 degrees and our dm, which is the minimum deviation, is equal to 37 degrees, we can be able to find the refractive index, which is equal to sine 1 over 2 bracket 60 plus 37 degrees all over sine 1 over 2, A is 60 degrees. So this gives us sine 1 over 2, 97 degrees all over sine 1 over 2, 60 degrees. Eta gives us sine 97 divided by 2 will give us 43.5 degrees all over sine 30 degrees. So our eta becomes sine 43.5 divided by sine 30 will give us 0.688 all over 0.5. So 0.688 divided by 0.5 is equals to 1.38, which we have our refractive index to give us approximately 1.4. So we have been able to calculate the refractive index of a triangular prism using our graphical method. So if you have been able to watch up to this extent, I would please that you do subscribe more, so that when next video comes out, you'll be able to see more. So it is very important that on this note that you know that due to experimental procedures, normally our refractive index and varies between 1.5 to about 1.7. So if you have done your practical and you get between 1.5 and 1.7 or a little less like 1.4, just as we have here, you are on track. That means your practical was on track. So see you next time in our video. I still remain Mr. Moses, taking you on practicals. So bye bye, see you next time in our next video. Don't forget, please subscribe and also like and leave a comment behind if you have any question to ask. Bye bye.